Hey guys, happy Thursday. Okay, so good news. We are done with Unit 8 now. So remember, you can always hit these little arrows on the side and you can collapse the modules. You don't have to look at that stuff anymore. We are on to Unit 9. So here's an overview of what Unit 9 is. Here's your video that you're watching. And then here is where you need to go grab your journal slides. It's going to ask you to make a copy of that file. And then you don't have to worry about like setting up a new journal. If you want to add them to your journal file that you were working on last 9 weeks, because Unit 9 is our last unit, you can do that. Or if you want, you can just keep that file separate. Either way, it's fine with me. Whatever you want to do. But these are your notes. This is what I'm going to be working off of. And then we have like a little activity we're going to look at. So let me pull up the notes here. So here they are. Oh, they're little. There we go. So here's your objectives. This is what we're going to learn in Unit 9. So you'll notice there's a recurring theme here, maybe that you're seeing, it's about something called exponential functions. Again, exponential functions. So this whole unit is talking about exponential functions. So this is a new type of function that we have actually seen, but we haven't talked about the key features. So that's where we're going to start. What all does an exponential function have to do with? So these are on the Google slide. I put text boxes so you can type all of your answers in. You can do that, or if you want to print them out, you can write on them. You can copy it down into a notebook, whatever your preference is for keeping your journal and your notes. You get some choice with that. Okay, so first thing that I want to talk about is down here at the bottom, and it's this equation. So you know something isn't exponential right off the bat. Look at where x is. So before, we've had things that are like linear. Now I'm going to come up and I'm going to kind of doodle around over here. So before, we might look at something that looks like this equation. Y equals 2x plus 3. Or we've seen something that looks like this, 3x squared minus x plus 10. But notice in both of those equations where x is. X is not a power. Exponential equations, now your x, what's changing is the power. The power is the variable now. A and B are both going to be numbers that you're going to know. They're going to be given to you in an equation. So let me give you an example over here on this side. You might have something that looks like this. Y equals 2 times 3 to the x. Now, the only thing that's getting the power of x here is the 3. I don't know why my thing is not finishing. There we go. So the power of x goes to 3. So what we're doing is we're changing the power on the 3 here. So the 2 would be our a value for this one, okay? Just like they're giving you in your form here. And your b value would be the 3. So A and B have some meaning here. So your A value is always the initial, or you can think of it as the starting amount. It's also always going to be your y-intercept of your graph. So if you're asked for the y-intercept, boom, it's the A value. Now remember, in all the other equations that we've ever talked about, our y-intercept is always something we can easily pick out. So if it's a linear, a line, remember your y-intercept's the number by itself. If it was a quadratic, remember your y-intercept was the number that was tacked on the end. Okay, awesome. So we're making some comparisons here. So again, I'm going to be able to find my y-intercept. So for this example right here, our y-intercept would be 2. That's where it's going to cross the y-axis at 2. Okay, well your b value, what is b? B is always going to be 1 plus or minus what we call a growth rate. Like how much is this thing growing by? How much is it changing by? We also call it the base. A lot of times it's called the base. So you may want to make a note of that. B is the base. Now, when B is less than 1, and you don't really have to memorize this, like you're going to be able to see this. We call it decay. I need to zoom in here. And when B is greater than 1, we call it growth. So basically it changes the shape of your function too. So if you look over here on the graph that you've been given, you notice the shape of this thing is like an L. Let me try to trace it so you can see it. So it's sitting right here and it zooms up. So you guys know when coronavirus first happened, and they were talking about it's growing exponentially. it means the numbers get really big, really, really fast, okay? So that's what's happening. We usually would start here. It's like saying, okay, right here at the y-intercept here, we had one case on day 1, on day 0. But on day 2, oh my God, we already had 2 cases. And then on day 3, boom, look how many cases we had all the way up here. So that's what it's saying, exponential growth. They were using a curve like this to actually model that. Now I'm going to erase that because I messed up my picture here. Okay, so what's something else we need to know? Well, again, we've talked about our y-intercept. So notice it's right there on the graph. It's where it's crossing the y-axis. That hasn't changed. It's that point right there. And so it's where it crosses our y-axis. And it's also your a value in your equation. Now, the next thing I want to talk about is growth and decay. So if you have what we call growth, that's what this one is. The function's going to be increasing. Okay, so I'm going to draw some lines. It's really hard to write on this. It's kind of small. Sorry, my handwriting's messier than usual. So notice how the function, if we trace it, it's going up from left to right. Do you see that? Zoom. That's increasing, right? You can see it's increasing. Sometimes they go the other way. They start over here and they go down this way. That would be one that we call decreasing. I'm going to erase that. So when it is decreasing, then we call, whoops, where's my pen here? We say it's decay. We'll talk more about that later on. Okay, so these graphs also have something really, really special. Okay, do you see this dash? It's vague, but it's here. There's a dashed line right here. Because what happens to this graph is it comes down, let me try to trace it, and it kind of hovers over the x-axis right there. It never actually touches it. So this is a weird word. I'm going to zoom in. Okay, it's a really strange word. So it meets up. It tries to like get really, really close to what we call this dashed line here. So this dashed line, so here's our function, but our dashed line is actually underneath it. Okay, see this dashed line there going? So what we call this, now this is weird, but this is what it's called. It's called an asymptote. Okay. I know it's a weird word, and the P is completely silent. You don't even pronounce the P. It's an asymptote, an asymptote. So what this asymptote is really an invisible line. That line's not really like graphed, but that's why it's dashed on there. So the graph gets closer and closer and closer to it, but it never actually touches it. So for the parent, now this is the parent. The equation for this one right here is y equals 0, because notice this dashed line is going through 0 on the y-axis. So you always look at where, if we were cutting that line through where it's getting really close to, where is it getting close to on the y-axis? So it's always a y equals equation. Okay, so the next thing that I would like to talk about is domain and range. Oh my gosh, my thing is like, I don't know what I've done here. My iPad's wanting to like audio record on me. Okay, so we talk about domain and range, which we have talked about before. So I want you to remember that domain, that's your x's, okay? So we're looking for, actually, I'm going to put that down here. So domain, we're talking about x's. So we want to know how far does this thing go left and right if I was to box it in. Well, notice on this end down here, that's an arrow that I just colored over. I was meant to trace over it. Okay, and then it also has an arrow up here. So it keeps going out forever and ever left and right. So your domain is always going to be all real numbers. This is similar to what we saw with our quadratics, our parabolas, all real numbers. But now your range, oh, okay. So if we're going to talk about how far is it going to go, and I'm going to erase this, guys, so I can illustrate. If we're going to talk about for our range, how far is it going to go up or down? Well, notice remember it has this asymptote where it gets really close, but it never actually touches y equals 0. But I can't box it in up here. So this is the one where we would draw our y in the middle. We would put our symbols. And we would say, okay, what's my smallest value? Well, we know it goes down to 0, but it doesn't touch it, so I can't put a line under that symbol. It never equals 0 there. And I can't box it in over here on this side because I have an arrow up here. So because I can't box it in, we just leave this side blank. It's a one-sided. So it starts at 0 and it goes up from there. You could also turn it around the other way and you could write it like this. Okay, same thing. So there's your domain. It takes up all the x's. It goes forever and ever left and right. But it'll start at the asymptote, which it can move. It doesn't always have to be 0, but for this one, the parent one, it's 0, and it goes up from there. It's all the y values that start at 0 and go up. Everything bigger, greater than 0. Okay, so this is your key features here. So let's go over to Canvas now. And there's an assignment here that's going to help you kind of look at some things and decide, okay, we're going to have to leave student view too. Oh, hang on a second. I think I locked this. Hold on just a second. Let me rewrite. Okay, so this is what it looks like. Exponential functions card sort. You're going to click this blue link right here, and you should have a submit button on this side. I don't because I'm the teacher. And it's going to open up something that looks like this. So here's what you're going to do. You're going to look at these. You're going to look at some graphs, first of all. And then you're going to look at some tables, and you're going to look at some equations, and you're going to decide, okay, is it an exponential or is it not an exponential function? You're going to drag these over. So first of all, let's talk about this graph. Now remember, here's our notes. You know what exponentials look like. They look like this L shape, and sometimes they're a backwards L shape. So you're looking for an L shape here. Is this an L shape? That's a quadratic, right? So that's not exponential. What about this line? Is that an L shape? Okay, I think you can answer that. Is it exponential or not? So look at your other graphs. Look at your equations. So when you're looking, let me zoom in here. When you're looking at your equations, what I want you to look for is, remember the key thing that I told you, and you got to look in your notes, go back to the notes for it. If it's exponential, where is x? X is part of the exponent. So look at this one right here. Is this x an exponent? Is it a power? So that's not exponential. But now look at this one. Aha, x is small. It's up at the top here. So it is exponential. And then look at your other ones. Decide, is x a power or is it a base? It has to be a power for it to be an exponential function. Now, for the tables, here's the best way to decide if a table is exponential or not. You need to look and see, well, is it changing? Are your y's changing by multiplication or division? If they are, then yes, it's exponential. But if you can't multiply or divide to get the next y, it's not exponential. So, for instance, this one right here, 2/5. Can we multiply or divide to get to 2? Can you take that same number and multiply it times 2 to get 10? The same number, multiply it times 10 to get 50. So what if we multiplied 2/5 times 5? Let's think about that. Well, that would give you 2. What is 2 times 5? Oh, it's 10. What is 10 times 5? Oh, it's 50. So this one is exponential. Because if I multiply by 5 all the way down my y column, those are the values I'm getting. Let's look at this one, 1/4. So what can I multiply 1 by to get 4? Well, 1 times 4 is 4. Is 4 times 4 16? Yeah, so we're multiplying again. So that one is also exponential. The tables can be the most confusing. That's why I want to talk about those with you guys. There's 2 more tables. Look at this one. Can I multiply anything by -4 to get 0? The only thing I can multiply -4 by to get 0 is 0. Okay, so -4 times 0 is 0. Is 0 times 0 4? No. See, we're not multiplying here to get this one. We're adding. It looks like we're adding 4 every time. So that one's not exponential. What about this one? Can I multiply 5 by anything, a whole number, to get 4? No. So I would have to subtract 1 to get 4. But then it looks like the rule is changing again because now I'm at 10. So there's no number I can multiply 5 by to get 4 and multiply that same number by 4 to get 10. So this one is not exponential. So that's your tables. That's the gist of the tables there. So look at your graphs, look at your equations, and then classify them as exponential or non-exponential, and then make sure you go back and hit submit and turn this in.